Hello, welcome back to my bench. Today we have a little bit of a review. One of my viewers asked me if I would review this little 35 megahertz to 4400 megahertz spectrum analyzer, RF generator, RF power meter that are about 35 to 50 bucks on eBay. And it will do what it says it'll do, but as far as I'm concerned, it's pretty much a decent lump detector, and we'll see why here in a minute. First of all, there are several different pieces of software that you can get for this, and the first one I'm going to show you is called WinNWT4, and this is version 4.09, and here it is. This is the little control panel that comes with it. Right now we've got it set up for 140 megahertz to 160 megahertz. 500 samples. That's 500 samples across the whole thing, and that gives it a pretty fair speed. And we've got no interrupt, microsecond interrupt. You can slow it down a little bit. And shifting. The attenuation doesn't do anything, and we're in sweep mode. It's got several modes here. They're not, for some reason, not showing up on the screen. Interesting. But there's several modes for it, and none of them are worth anything. SWR for antenna. I don't know how it's even going to do that. Impedance, spectrum analyzer, and spectrum frequency shift. None of those work worth a hoot. The only one that works is the sweep mode. It has a small amount of math correction built into it for the software itself. It will allow you to measure the 3 dB points on your signal where it rolls off the edges down to 3 dB. It'll show you a 3 dB and 60 dB shapes. It turns on markers, and it'll let you do an inverse for some reason. You can select your Y maximum and your Y minimum, and you can do a shift your cursors back and forth to get it dead on frequency. Well, all of that stuff is neat, and sounds really cool, but it's not. Here, I'll show you how this thing works. This is the window here, and I have taken one scan at 150 megahertz. The output is coming from my Motorola R2200A communications service monitor. I know it's clean, and I know it's on frequency. If you look over here, you can see that we have no data yet on this thing. But if I point up here into this, now it's telling me that my cursor one is at 150.100160 on channel 1 at minus 26 dB. Well, that isn't correct because I'm feeding it at minus 43 dB. You'd have to do the math to figure it out. So let's, on this scan, let's take a look at what the 3 dB and Q shows you. Thank you, phone. And the 3 dB shows you over here that your 3 dB points are 280.560 kilohertz, which is dead wrong. Because we look up here, you can see that this side of your 3 dB is pointing at the 3 dB down point on this side of your waveform, and the other side is showing the center where this little dip is. That little dip is the big problem with this if you want to use it as a spectrum analyzer. If you want to use it as a lump detector, it does a pretty good job. I mean, just showing you where you're at. It's kind of deaf. Like I said, right now I'm feeding it minus 43 dB, which is 1.5 millivolts, and that's if I go down much. Let's take it down 10. Do another sweep. If I can find my mouse. And down 10. So if I go down to 50 microvolts, that's what you get, and that's all you're going to get. It's just not it's just not there. It's just not enough sensitivity on it, but it'll do okay if you're out in the field underneath an antenna or something. I suppose it would do fine. However, for these purposes, we'll leave it at 1.5 millivolts. Do another single sweep. And bring my down to 0. Okay, so now I've got 0 from the top all the way down to minus 80. Now, if you look, we're not even getting minus 80. We're getting more like our noise floor is between 50 and 60 on one end and 60 and 70 on the other. So that's not real good. That's not great, and a lot of things get lost in the noise. So that's what it does on that program, which is not terrible. And like I said, it can show you the lumps. We'll do a continuous here and show you that it's not too bad as far as refresh rate goes at 500 samples. Now you can take this thing, if you want to, all the way up to, 9,999 samples. And we'll do a sweep, and here it comes. You expect this. This is normal. I mean, you're doing like 10,000 samples, but in 10,000 samples, you can see that little notch goes all the way down to the bottom. I mean, right down to the bottom of the thing, and that's just no good. Let's stretch this out a little bit. Since we're doing 150 megahertz, we'll go from 149 megahertz to 151 megahertz, and give it a continuous sweep, even on 9,999 points. Watch for the notch. There it is. So it really, that notch just throws a crimp into everything. And we're at minus 60 dB down as far as it's concerned. I can put this up here at its high peak, and its high peak is showing me minus 23.8 dB. So, and I'm looking at 149.796. It's not bad for that, but it also has some other things that it will do. It has a VFO, and it has a watt meter, and the watt meter doesn't work. I mean, it just doesn't work. If I take the watt meter here and I go to 150 to 200 megahertz, 0 dB attenuation, and this hang thing, it's the way that they display it, or actually figure out the math. It says I'm doing minus 52 dB. It's 5.7 nanowatts, or 532 microvolts. Well, let's take this down 10 dB, and nothing changed. It's just, no, it's not doing anything. So that doesn't work. Only thing that works on here is the sweep mode. So there's that one. Let's take a look at another one. And the other one is WinNT 4W. Wow, what have I got here? Here it is. This one, this is the, what does that say? Net tester or something or other. It is a little bit better in some ways. Let me make it bigger here so you can see it. But it's still not what you'd call great. I'm sitting at 147.5 to 152.5. And if I hit a single sweep, it's not working. Whoops. Single sweep, there you go. It's got exactly the same thing we saw before. It's still 60 dB down. But what this does is it lets you set things up a lot easier. You can do a center frequency and a span. That's a lot easier to do. And it also lets you set up some other things in here. You can do dB minimum and maximums, and it'll print it across the page for you. 150 megahertz minus 34.7 for a max, and minus 62.9 for a minimum. That's nowhere close. I'm doing 0.51 millivolts out of this thing right now. We go up to 0 and do another single. It's bigger, but it's still saying we're at minus 23, and we're actually at minus 43. So the two of them match, but you got to do the math to figure it out. It's not a direct readout for you. This one also has VFO. It also has the milliwatt meter. Milliwatt meter is, again, not accurate. It's saying minus 85 dB. For the hang values, let's see, attenuator's at 0. It's not right. If I take this down 10 dB, nothing changes. So, and this one will supposedly it shows you how to do impedance matching, get into the middle of it and into it. I am doing this at 50 ohms, by the way. Anyway, so there's that one. It does work. It's a little bit better. It allows you to go to 2,000. This one only goes to 2,000 samples. Still with the notch, and there's nothing you can do about it. Anyway, so there's that guy. And then what we got for the other one, the latest version is not on the board anymore. Oh, that's right. Hang on, I got to go get it. Did that work? Yeah, that worked. And this one's called VMA Simple, and this is the best that's available to use with this thing at this point. So we'll set this one up. You can do a center frequency, which is nice. We'll do our center frequency at 150. Yeah, you kind of got to type these in. There is ways to do it, but it's much easier to do that. And I want a span of 4 megahertz. And we'll do a start. There it is. And it's just like the other ones, almost exactly. This has little things that are that you can put in here, like you've got your frequency presets. If I want to do stop it and do 2 meters, there's nothing. I haven't got anything plugged into it for an antenna. FM, this is the whole FM section. Would show you that, and that works fine. But you can set these all up. Now, there's my 150 right there. Well, it's not actually. That's 100. That is a birdie right there. I don't know why that's there, but there's a birdie on this thing at 100 megahertz. So these programs work, but for the most part, they're just kind of lump detectors. However, this one lets you play around with frequency outputs that actually work. You can use the output of this, and I'll show you how that works. Set this up, bring in the spectrum analyzer. Spectrum analyzer is on. We want to do this at what am I set up? My center frequency is at 150 on the spec an, and we'll hit start. There we go. So you can get 150 megahertz out of it. That's not bad. What's my span right now is 10 megahertz. It's kind of weird. It won't stop. This program won't let it stop unless you do something else, and then it'll stop. But let's take a span on this of 150. So let's do second harmonic would be 300. So I want to do 600 megahertz and start it. Amplitude. Look at that. We got peak search on my 149.5, 150 megahertz. We're down at what? Minus 3.18 dB. If I can throw in 20 here, just to show you, I'm not overloading my spec analyzer. There's 20. There's a lot of attenuation. And the search next right peak is, look at that, 450 megahertz. So it'll be 150, 250, well, it'll be 300, 450. So there's a harmonic that's down 15 dB. So it's only down 16 dB from your main, which is at 150. That is not good, folks. That's not good at all. Let's set this thing up. Span, full span. Look at that. We've got peak searches. There is 150 megahertz, 450, 600, 750, 1.05 gigahertz, 1.35 gigahertz. So it's putting out a lot of harmonics. A lot. So let's stop that. As a matter of fact, let us do this. Let's go to, this one is a harmonic generator. So let's see what this does. I want my fundamental to be on 150 megahertz. And we'll turn that on. Okay, no, off. 150 megahertz. Turn it on. And it's doing exactly the same thing. And if we do our peak searches, next peak right, there's 300, 150 times 2. So you're about 45 dB down on your second harmonic. Next peak right is minus 15, so you're only like 15 dB down on that one. Yeah, marker. That harmonic is, that's 48 dB, so it would be 47 dB down. So what I'm saying is, you can see it ain't the cleanest little transmitter in the world. And it doesn't seem to make a difference on whether you're on regular or creating harmonics. And then you have a sweep generator. So let's take the sweep generator from 140 140 megahertz, and my end frequency 150 megahertz. So, and steps of I don't know, 100 kilohertz, and pause of 100 milliseconds, and let's see what it does. I can't see it because I'm going to be my frequency, center frequency, 150 megahertz, and my span, I want to be about 2 megahertz. Not enough. 10 megahertz. So you can see it is when the poor thing will catch up with it. Let's do a pause here of 500 milliseconds. Nah. Let's see. There we go. Step it to 50. So it will do a sweep. I don't know what all that crap is it's throwing in there, but it's definitely throwing something in there. We're going from 143, 145. There we go. 147 to 150. But it's meh. It's okay. So there you go. It does work as a lump detector, and you can use it, I guess, as a frequency generator, but it's worth about $38 or $40 or whatever you spent for it, I guess, but you still got to carry around a computer to be able to read it. In a pinch, yes, it'll do. But what I'd like to get a hold of one of those little handheld spectrum analyzers, those Tiny SA Ultras. That's what I'd like to have. They seem to work fairly well from what I've been able to see. And if I ever get one, though, I'll show you how it works. Anyhow, guys, there you go. Go through all the software for this little spectrum analyzer, RF signal generator, and RF power meter, which it's not, and whether it's worth anything. Final thoughts. If you can get one on sale for $10, I guess. But I don't think I'd probably buy it. I even bought this one, and it's in a metal case to see what it was like. I guess since we're here, let's open it up just for the fun of it and see what's in it. These are Philips, and there's a bunch of them. I've never opened this. I never really cared that much. Like I said, I carry this around in my pack just so I can say, is your STL transmitter actually transmitting, like at the antenna? Well, I don't know. Let me pull out the lump detector and see. That's what it's good for. All right, here we go. Well, there's what's in it. Fairly nicely made, at least in the box. See if we can figure out what some of these things are real quick. Wow. This very small, to say the least. So let's see. Gotta get my glasses straightened around. Wow, that is, get out of here. That is really hard to read, even with my gate glasses on. So this one, ABF 4351 BCPZ. I don't know. This top one, this is the main guy. This is the ST32 Micro up on the top. That's what does all the work. That is a CH340G. Bunch of diodes. Signetics 9162. And what is that? 9162? No, 916. And another 106. Little 8-pin packages. 80 devices. 8307. And whatever this M810 is. And a crystal. That is, the printing is so small I cannot read it. So I don't know. Anyway, that's what's inside. There's no sense tearing it apart anymore. It's just parts. And they're doing their stuff. There's your programming pads are over there too. Anyway, there we go, guys. That's what it is. And that's what it does. So, hey, thanks for stopping by. And don't forget to hit the subscribe button down there. Still, 5% of my viewers are actually subscribed, 5.2%. And hit the like button if you like this kind of stuff. And I've got a channel over on Patreon, patreon.com/AERVblog if you want to support me. That'd be wonderful. Hey, thanks a lot, guys. Till next time.